Instantiation in Verilog/SystemVerilog. Before understanding instantiation, let's talk about function calling. If you already know any programming language like C, Python, or Java, you know what it means to call a function. If you are completely new to coding, no problem, you will understand now. Function calling, software concept. In programming, we create a function once. Then, whenever we need that functionality, instead of writing the same code again, we just call the function. Example in C. Add A, B. When we call a function, the function executes, it runs, it returns a value, then it stops. This is software behavior. Here is the example code of C. Here, we called function 3 times. Let us consider function as a calculator. We use same calculator 3 times. This is function. Now in Verilog/SystemVerilog. In hardware design, we don't call circuits. We build hardware. If we need the same circuit multiple times, instead of rewriting the entire module code, we instantiate the module. What is instantiation? Instantiation means creating a physical copy of a module inside another module. Example: AND gate is the module type. U1 is the instance name. If you create another instance, you can name U2. You can name any name to instance, also to module. You can name Tony Stark, you can name Bahubali, etc. Your wish, but there are some rules we see in next topic. We are creating a physical AND gate inside top. Why do we say instantiate and not call? This is very important, because hardware is not executed like software. When you call a function, it runs temporarily, then it disappears. But when you instantiate a module, you create actual hardware. It exists permanently in the circuit. It works continuously. Real-life analogy. Calling a function is like using a calculator to compute 2 plus 3. It calculates and finishes. Instantiating a module is like adding a new physical calculator to your desk. Now it permanently exists there. We don't call hardware. We build hardware. That's why we instantiate modules. We are creating physical circuit blocks, not executing instructions. Types of instantiation. We can instantiate a module in 3 types: positional port mapping, named port mapping, wildcard port connection, .*. Only in SystemVerilog, not in Verilog. 1. Positional port mapping. In positional mapping, connections are done based on the order of ports. That means the order must match exactly with the module definition. In AND gate, the order is input A, input B, output C. So if we use positional mapping, AND gate U1 D, E, H. This means A gets connected to D, B gets connected to E, C gets connected to H, because the order matches. Important: if you change the order by mistake, the connections become wrong. That's why positional mapping can be dangerous in big designs. 2. Named port mapping. In named port mapping, we connect using the port names. Here, port A of AND gate connects to port D of top module. Port B of AND gate connects to port E of top module. Port C of AND gate connects to wire H of top module. Now, order does not matter. Even if you write AND gate U1 .C equals H, .A equals D, .B equals E. It will still work correctly. This method is safer. This is recommended for beginners and used in industry. 3. Wildcard port connection. Only in SystemVerilog, not in Verilog. This is an automatic connection method. Only use if the signal names in both modules are exactly the same, we can use AND gate U1 dot star. But for this to work, names must match. Example, look at given code. Port A of AND gate connects to port A of top. Port B of AND gate connects to port B of top. Port C of AND gate connects to port C of top. Automatically, no need to write each connection. Important, it works only in SystemVerilog and names must match exactly. If you try this in Verilog, it will throw error at your face. Multiple instantiation in Verilog/SystemVerilog. Till now, we instantiated one module one time. But in real hardware design, we can instantiate multiple different modules, and we can instantiate the same module multiple times. Let's understand using a simple example. Here, inside this module, we instantiate AND gate 2 times. We instantiate OR gate 1 time. AND gate U1. This creates the first AND gate. AND gate U2. This creates another AND gate. Notice, same module, AND gate, different instance names, U1, U2, different connections. This means we created 2 physical AND gates in hardware. OR gate U3. This creates 1 OR gate. Important observation. Look at these 2 instantiations. They both are same, you can write in either ways.